Hello and welcome to part 2 of lesson 12.5. Today we're going to look at the dependent events. In part 1 we looked at independent events, and remember, independent events mean that they do not rely on one another. So you flip a coin, you can get a heads or a tails. Then you go back and you flip another coin, you still have that same probability of getting a heads or a tail the second time. Today we're going to look at events that are dependent, and remember the word dependent means that it's going to rely on another outcome. So by definition, it says dependent events are events in which one event affects another. So this right here is the key part. One event affects the other. Okay, and they use the example of choosing 2 cards from a deck and not replacing the first. So if you choose, let's say, a 2 of hearts from a deck of 52 cards, and you want to select another card, if you don't put this 2 of hearts back in that deck, so let's say the probability of selecting a 2 of hearts is a 1 out of 52. Now let's say on your next choice, if you go and you select we'll say a 3 of hearts, now the 3 of hearts is a 1 out of 51 because you did not replace the 2 of hearts back into that deck, so there's only 51 cards available. So this would be an example of a dependent event. So in this case, like, your denominator is going to depend on whether or not you put this 2 of hearts back into that deck. And sometimes our numerator can be affected as well. We could look at this and say there are 13 cards in a deck, for example, 13 cards of each suit. So if I want to know how many hearts, or what my probability of selecting a heart would be, the first time when I do the 2 of hearts, we'll do this color in red. So here I'm just looking at hearts in general. Okay, so if I select a 2 of hearts out, I know that I have 13 possible hearts and a deck of 52. But now when I go to do once I pull that second card out to select a heart, I now have 12 out of 51 choices, because this 12 here is equal to the original 13 minus the heart that I've already taken out, and then the 51 means that I had 52 cards available and I subtracted 1 out as well. And then just like the previous or the part 1 video, we would multiply those probabilities together. So for 2 dependent events, which we're going to call A and B, the probability of both events occurring is the product of the probability of the first event and the probability that after the first event, the second event will occur. So you have the probability of your first event times the probability of your second event, just like what we were doing when we were dealing with independent events. Now, if we take a look at example 4, we'll see how this works. So example 4 says, 3 girls and 2 boys volunteer to represent their class at a school assembly. The teacher selects one name and then another from a bag containing the 5 students' names. What is the probability that both representatives will be girls? When the first student is selected, it looks like we have 3 girls and 2 boys. So we have a total of 5 students possible, and there are 3 girls in the first draw. Now in the second draw, because I've already taken 1 out in the first draw, we have 4 total students. And if I drew a girl in the first draw, that means I'm now going to have 2 girls in the second draw. So now, to find my probability of both of these students being girls, I'm going to multiply them. And we end up with 3 times 2, which is 6. 5 times 4 is 20. And if I reduce this fraction, we end up with 3/10. So the probability of selecting 2 girls out of the 5 students would be 30%, or 3/10. Now for example 5, we have the same scenario where we have our 3 girls and 2 boys that volunteer to represent their class. The teacher's going to select 2 students at random, and it says that we want to find the probability of selecting a boy first and then a girl. So Again, we have our first draw, and we're going to have our second draw. So if I want to know the probability of selecting a boy on the first draw, there are 2 boys out of the 5 students. And on my second draw, I want to draw a girl. And at this point in time, we still have 3 girls, but we only have 4 students to choose from. So again, we're going to multiply these, and I end up with 2 times 3, which is 6, 5 times 4, which is 20. When I reduce that fraction, I end up with 3/10. So my probability is going to be 3/10, or again, that same 30%, to have 1 boy and 1 girl. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.